All right, today we're going to demystify something that's, well, kind of the unsung hero of the internet, database replication. It's the magic that keeps your favorite apps running 24/7, and we're going to pull back the curtain and see exactly how it all works. So picture this. You're streaming the season finale of that show you love, or maybe you're about to snag the last item in a huge online sale, and then bam, everything just stops. What happened? The main database crashed. That right there is the exact nightmare scenario that database replication was built to prevent.
So, here's how we're going to break it down. First, we'll cover what replication actually is. Then, we'll get into the big benefits, availability and speed. After that, we'll look at the playbook for how it's actually done, find some examples out in the wild, and then wrap up with the trade-offs, because there are always trade-offs.
Okay, let's get right to it. What are we really talking about when we say database replication?
At its heart, the idea is actually pretty simple. You've got your main or primary database, and you're just constantly copying all of its data to one or maybe even a bunch of other databases, which we call replicas. The whole point is to keep these replicas perfectly in sync with the primary, creating this awesome safety net of identical, up-to-the-minute copies.
Here's an easy way to think about it. Imagine your data is like a priceless document in a super secure bank vault. You wouldn't just keep the one and only copy there, right? No way! You'd make photocopies and stash them in other bank branches, just in case. So if anything ever happens to that main vault, your info is totally safe. That's replication in a nutshell.
Okay, so we're making copies for safety. Got it. But why is this so incredibly critical for pretty much every app you use? Let's jump into the next section and see how this one simple idea leads to some massive, massive benefits.
Really, replication gives your application 4 superpowers. You get high availability, which is just another way of saying constant uptime. You get disaster recovery for protecting your data. You get scalability to handle huge amounts of traffic. And you get geographic distribution for lightning-fast speed. So first up, and this is the big one, high availability. This is the promise of an app that simply doesn't go down. If your primary database server just decides to give up the ghost, maybe the hardware fails or something, the system can just automatically flip a switch and make one of the replicas the new primary. And for you, the user, you notice nothing. Zero downtime. It just keeps working.
And that leads perfectly into the next 2 points. First, replication is your ultimate insurance policy against losing data. That's your disaster recovery. But it's also a serious performance booster. See, instead of sending every single request to that one primary database, you can spread all the read requests out across all the replicas. This balances the load, and it keeps your app feeling super fast and responsive, even when traffic goes crazy.
And finally, in this totally global world we live in, speed is everything. So, what if you could put replica databases in data centers all over the world? One in Tokyo, one in London, one in São Paulo. Well, now, you can serve users from the database that's physically closest to them. This totally slashes latency, making the whole experience feel incredibly fast, no matter where you are.
So the benefits are super clear, but how do you actually do it? How do engineers make this all happen? Well, that brings us to the playbook, the different strategies and models you can use.
Okay, the first big choice you have to make is all about timing. You can go with synchronous replication, where a write to the database isn't considered done until the data is safely copied to the replica. It's way safer, for sure, and guarantees consistency, but it's also slower. The alternative is asynchronous. Here, the primary says got it right away and then copies the data in the background. It feels much faster for the user, but you run the risk of a tiny delay or replication lag.
The other huge piece of the puzzle is the architecture. A really common setup is called master-slave, or maybe more accurately, primary replica. You have one primary database that handles all the new data, all the writes. The replicas are basically read-only copies. Super simple, great for apps with lots of reading. Then you've got master-master, where multiple databases can accept writes. This is kind of essential for those globally distributed apps we talked about, but man, it is way more complex to keep everything in sync.
All right, enough of the theory. Let's ground this in reality. Where are you actually seeing replication in action, like every single day?
Well, when you load a YouTube video and the title and comments pop up instantly, that's because all that metadata is replicated on a server near you. Or when you buy something during a massive online sale, replication is working behind the scenes, making sure your order details are copied safely so the system doesn't crash. And, most importantly, when you make a bank transfer, Replication is there, guaranteeing that transaction data is copied immediately so there's zero chance of it ever being lost.
Now, as powerful as this is, replication isn't some kind of magic bullet. If you're going to implement it, you have to be ready to deal with some very real trade-offs.
There are really three main costs to think about. First, storage. It's obvious, right? More copies means you need more servers, more space, and that costs more money. Second, there's that lag we talked about. With asynchronous replication, there's always a chance your replicas are a split second behind, and for some applications, that's a deal breaker. And finally, complexity. Trust me, keeping multiple databases perfectly synchronized across the entire planet is a huge engineering challenge. So here's the real takeaway. Database replication is basically the engine that powers the resilient, always-on world we all depend on. But it creates this fundamental tension for every engineer, a constant balancing act between perfect, consistent data on one side and pure, raw speed and performance on the other. And learning to master that trade-off, that's what really separates a good application from a truly great one.
So, understanding replication is a fantastic start, but it often goes hand in hand with another really powerful technique for scaling. And that leaves us with one final question to think about. How does making copies of your data compare to splitting it up into smaller pieces, a technique called sharding? We'll dig into that one next time. Thanks for joining me.